Cleaning air conditioning units is a tedious and costly work, especially when there are many units to manage at once. The technicians will not only need to climb up the ladder to dismantle every split unit in person to check for filtering issues, they will also need to carry test equipment as they walk long distances or climb hard areas to manually check the compressor outside of the premise. Compressors tend to overheat or overrun when the environmental temperature in the room changes constantly due to frequent door opening. And as cold air leaves the building, uncomfortable occupants tend to blast the AC on high to achieve the set indoor air temperature, stressing the compressor and wasting more energy. Here, Tanand introduces wireless IoT sensors and IoT hardware that can be deployed cost-effectively with minimal downtime. With the energy meter measuring compressor abnormalities, the remaining three act as coil performance sensors coupled with extra energy analytics to detect whether the coil, filter, or compressor need maintenance. In this case, we will show you how PCM works in reducing preventive maintenance workload through accurate detection of filter conditions. We simulate a situation where a dirty filter can be measured with the coil performance sensors, indicating that there is an accumulation of dust with filter condition in red. With that, the system will record a high energy usage as the aircon needs more power to churn out the same temperature of cold air through a dirty filter. Whereas you can see when we removed the polystyrene to simulate a clean filter, the filter condition will be in green, indicating that there is no clogged or dirty filter that is using extra energy. All these are achievable without having any technician at site for manual checking. PCM can also tap on hidden energy saving opportunities and lengthen compressor lifespan through a change in temperature set points. With our TX controller, which includes a built-in IR controller, temperature can be preset at certain set point through a web dashboard remotely. Effectively changing the temperature set point to an optimal level will reduce the compressor workload. The compressor workload is then measured by the energy meter while analyzing energy consumption trends in real time. All historical data can be retrieved easily through our web dashboard as well. With the energy meter measuring how long the compressor has been running in optimal condition and detecting simultaneously when an energy surge happens, we can reduce compressor runtime by a wide margin, achieving not only significant energy savings, but also increasing compressor's lifespan as it reduces abnormal power consumptions and sudden breakdowns caused by overrunning, overcooling, or overheating of compressors. If the auto-regulated temperature is not up to the user's comfort, you can reduce their complaints through the QR code that makes immediate set point changes to the aircon to ensure maximum occupancy comfort. The simulation has shown results of achieving 22.9% energy savings while increasing compressor stop cycles by 300%. The more aircon units you have, the more significant your savings would be. Additionally, PCM provides a demand-based maintenance scheduling that will automate and prioritize the PPM work order based on machine health status. This is only made possible by our real-time sensor benchmark. This feature reduces workload. It will also be your KPI tool to check on the quality of the maintenance work done since the HealthPoint system re-evaluates itself. Achieve all the results below with the Tanand Predictive Condition Monitoring. IoT is important to reduce workload in terms of PPM and compressors. IoT also helps to achieve energy savings and reduce complaints, especially for facilities maintenance companies. For more information, visit us at www.tanand.com.my.